All right, an intro lesson for chapter 2. We are looking at families of parabolas. So in chapter 1, we graphed a lot of lines, looking at linear equations and linear functions. In chapter 2, we're going to be looking more at parabolas, a U-shaped kind of graph. So we're just looking at how different things that we add to these equations impact what our graph looks like. So we have three different graphs here, right? I have x squared. And I could build a table of values, but we can also rely on our calculator to help us with that, right? So I can type x squared into my graphing calculator. I can go to second graph and the table function. It's scrollable, right? And I can see points that I can graph on this coordinate plane. I'm going to graph this first one in black, right? So I have a point at 0, 0, and then I have points at negative 1 and 1, positive 1 and 1, and then negative 2 and 4, positive 2 and 4, and then negative 3, 9, positive 3, 9. Right, and I'll just do my best to connect those with a smooth line. And so that shape is called a parabola. What we want to do is look at how can we move that graph around on the coordinate plane. So for our next example here, x squared plus 4, I'm going to switch over to red. Right, and I can type that into my y equals as well. If I want to leave the original equation on there, I can pop down into y2. Right, so x squared plus 4. And you might want to make some predictions about what you think that is going to do to the graph. Okay, how is it going to move that parabola on the xy coordinate plane? Right, so if I hit graph, there's my first equation, and then in comes my second. Right, and I can again go to table. Right, and I can see a table of values here. So I have points here, here, and at negative and positive 2, 8. Right, so that action, that plus 4 on the end, shifted my entire graph up 4 units. So knowing that, it should be pretty obvious then what this last equation is going to do. It's if you're thinking in terms of geometry, these would be like translations, right? They're moving the graph around. So if I hit graph again, it's x squared, and then I have my x squared minus 3 moves that original graph down 3, right? And I could actually plot a lot of points on this coordinate plane because I have a lot of room, but I'm not going to graph them all. I'm just going to graph some of them here. Let's go with 3, 6. And I see that graph got shifted down 3 units from the original. Okay, so anything that we add or subtract after the square, if we are in what is called vertex form, shifts the graph up or down accordingly. So looking here, we still have that original x squared graph, and I'm going to go ahead and graph that one again in black. Right, starts here at the vertex. Looks kind of like this. Okay, now I have x plus 4 in parentheses and then squared. Right, now we can predict, since that plus or minus after we squared moves our graph up and down vertically, we can probably assume that this plus 4 inside parentheses is going to move our graph horizontally or side to side. Right, so here is x plus 4 all squared. So let's graph that up. There's my x squared, and then x plus 4 squared. And what we see is this actually shifted the graph to the left 4 units, which is kind of surprising, at least to me, because it is x plus 4. My brain says, oh, it should move it right 4. But what we are going to find is things in the parentheses that happen in the parentheses, it is shown up on the graph as opposite of what we see. Right, so this x plus 4 shifted that vertex to minus 4. And if we think, what do I need to sub into x and then add 4 to it, and then when I square it, I get 0, right? I need that negative 4 to make the 0 squared equals 0, right? So mathematically, it makes sense. Just get a quick glance, you would think, oh, it moves it right 4, when in reality, it moves it left 4. Knowing that, make a prediction about what is going to happen to x minus 3 all squared. Type that in. Right? And we can probably predict then that that is going to move that vertex right 3 units. Okay, so I get my graph here. So what we do in the parentheses moves the graph side to side horizontally. For our last little example here of exploring families of parabolas, we have both the both translations happening, right? We have the horizontal happening inside the parentheses, and we have the vertical happening after the parentheses. Right, so here is my original equation, and for this one I'm actually going to switch into Desmos to kind of show how that would work. So here is Desmos, and I'm actually going to type in all 3 equations here, y equals x squared, and I can type in y equals x plus 6 squared minus 5. And I'm going to type in, while I'm at it, y equals x minus 4 squared plus 6. Okay, and the nice thing about Desmos is it gives us a nice color-coded graph. Zoom out a little bit there. And we see that our original x squared, we can change that to black like we'd been using. Change that to black, and we'll change to red and blue just to kind of keep up with what we've been working on. Oh, red and green will work. Okay, so we see that our x squared plus 6 actually translated our graph left 6 and then down 5, right? So my vertex is now here, right? And then it has that parabola shape. The x minus 4 squared, right? This x minus 4 right here is going to translate my vertex right 4, right? Right 4, and then up 6, right? From right here. So my vertex is now going to be here. Right, so that's just a quick review from your Algebra 1 days on parabolas, and just an introduction to how these parabolas get shifted around using vertex form.